Hello. In this video, we are going to examine the activation of the carbonyl group by protonation. Notice at the left-hand side, when we have a carbonyl group, that the bond is polarized with a partial positive charge on carbon and a partial negative charge on oxygen. The partial positive charge on carbon makes it electrophilic. If we protonate the group, we get a shift of electrons from the pi bond. So notice the diagram in the center. So an electron pair that's in the pi bond is transferred to become a lone pair on oxygen. In effect, we get this movement of the positive charge from the proton to the carbonyl carbon. Remember, the more electron deficient, the more positively charged the carbon is, the more electrophilic it is, the easier job a nucleophile is going to have attacking at that particular position. So one of the main reasons why we do this activation is to help in nucleophilic substitutions and additions if we do it with a weak nucleophile. As a way to discuss this quantitatively, what we did was we found the partial charges on the carbonyl carbon in aldehydes and ketones, first under the circumstance that they weren't protonated, and then under the circumstance that they were protonated. So the four aldehydes that we used were formaldehyde, acetaldehyde, propanal, and butanal. So these are the aldehydes from 1 to 4 carbons. We looked at 2 ketones, acetone and 2-butanone, so a 3 and 4 carbon ketone. And we noticed that in every case that the partial charge on the carbonyl carbon increases substantially upon protonation. This is formaldehyde, and the partial charge on carbon is 0.223. This is protonated formaldehyde, and now the partial charge on the carbon is 0.376. Here is acetaldehyde with a partial charge on the carbonyl carbon of 0.340. Here is protonated acetaldehyde, and the partial charge on the carbonyl carbon has now risen to 0.404. Here is propanaldehyde, if you like, and the partial charge on the carbonyl carbon is 0.372. And we compare that to the protonated propanal, where the partial charge on the carbonyl carbon is now 0.449. Here is butanal, and the partial charge on the carbonyl carbon is 0.367. And for the protonated butanal, the partial charge on the carbonyl carbon is 0.414. For our final two examples, we're going to look at ketones. The first ketone here being acetone, and the partial charge on the carbonyl carbon is 0.403. For protonated acetone, the partial charge on the carbonyl carbon is 0.512. For the ketone 2-butanone, the partial charge on this carbonyl carbon is 0.378. If we have the protonated 2-butanone, then the partial charge on the carbonyl carbon is now computed to be 0.537. Now we can take a look at table 1 one final time and notice that we've computed the partial charges on the carbonyl carbon of these aldehydes and ketones, both protonated and unprotonated, and we see that in every single case, there's a substantial increase in the positive partial charge on the carbonyl carbon, thereby making it more electrophilic, more susceptible to nucleophilic attack, especially by weak nucleophiles. I thank you very much for your kind attention. Stay healthy, stay safe, and as always, have a good one.